projection, right? And stretching along x-axis, stretching along y-axis. So we can do like this. So yes. Otherwise, we can discuss. So yesterday we discussed about the formation of linear transformation by using the base set. And we also discussed, we proved a very important result. Share again. Right? This is the transformation will be basis, then it will be to represent the coordinate system is using standard basis only. So if someone asks you, then that what angle we can take with you can accept 180 degree, because in 180 degree we cannot express the system. They will be linearly dependent. We need linearly independent vector. If you understand, if you understood the concept, then you can write yes, so that we can move forward. If you have any doubt, then you can ask. Let us take example. So we did this result, we did proof of this result yesterday, this theorem. So the important part of this theorem was any linear transform from V to W is completely determined by its action on basis of V. So here in this example, we are taking a basis 1, 1 and 1, 0, 0, because our V is R cube and these three vectors are linearly independent. So any three vectors linearly independent in R cube form basis. So this is a basis set, and its images, we have given the images of this basis set. Let it be V1 and V2 and V3. So we have given the images of this basis, and image of this basis set is, first one is 2, 1, second. So I have intentionally taken, because we have also discussed that if V1, V2, V3 are independent, then there may or may not be linearly independent. So that is why I have taken this example in which images are again linearly dependent. Same images are here. So we will find the linear transformation by using the basis and its image. So as we know, let B be the basis set, which is 1, 1, 1, 1, 1, 0, and 1, 0, 0 dependent. We can check the linear independence by various ways. We can take a determinant of these three vectors. If it is non-zero, then these are linearly independent. We can also use row echelon form. I can reduce it to row echelon form if number of rows non-zero rows are 3, then they will be linearly independent. So that is why it is linearly independent. I will express any vector x, y, z of R cube in terms of this. So if I want to write x, y, z in terms of alpha v1, beta v2, gamma v3, then alpha times 111, beta times 110, times 100, right? I want to find this beta gamma. So I will get 3 equations. First one is alpha plus beta plus gamma equals to x. Alpha plus beta plus gamma. Yes, sir.
Student, so that it's good if you discuss with them.
Yes, sir. Yes.
Avantika.
Yes, sir.
Yes.
Yes. Avantika, what will be the next equation?
Sir, alpha
Alpha.
plus beta
Hmm.
plus 0 is equal to y.
Okay. Last.
Alpha
Alpha.
plus 0
Hmm.
plus 0 equal to z.
So I want to find alpha, beta, gamma in terms of x, y, z. Therefore, I will
Yes,
get
sir.
alpha equals to z. What will be beta?
अल्फा अल्फा की जगह हम z पुट करके निकाल
Then
सकते हैं.
क्या आएगा?
So y minus z.
y minus z.
Okay. Then gamma x minus y minus x minus
minus
y.
Minus 2z, sir. Minus 2z.
So let me. Gamma is minus z.
x minus
X
y.
minus y returned. So therefore, p of x equals to. Now t is a linear transformation, so I can write t of this whole image as alpha times t of 1 1 1, beta times t of 1 1 0, and gamma times t of 1 0 0 and 1 0 0. Now the value of alpha is z, and value of it is already given, so it is 2 1. In fact, all the images are 2 1. Into to 1 again, and value of gamma is x minus y into 2 comma 1. Then the sum will be 2z plus 2y minus 2z is plus 2y plus 2x minus 2y is plus. So first answer is plus 2x. It is a simple algebra, so I'm not involving you. Y plus x minus x. So this is our resulting. So I hope if you have any doubt, then you can ask. Please write yes if you have no doubt. In this way, we can unique with respect to unique information. If you want, it is from r cube to r square. There is some projection here. So our next topic is range of linear transformation. Very important part. So if V and W be two vector spaces and T be any linear transform, then range of T denote of V under T means if I denote this vectors of V, all the images of vector space V. So RT equals to T such that V belongs to V. Sir, please call any student.
Amandeep.
Yes, sir.
But please reply for this question. What will be the superset of RT? सबसेट है V का या W का?
V का.
Okay.
Aman, do you know about range of
Range of
set.
function.
Range of function, yes.
Yes, sir.
Yes,
A
yes.
point, if
Yes, sir.
it is A set and this is B set, the mapping is defined from A to B. If this is X and this is X, A, or it is a subset of B.
Sir, D,
It is
subset
a
of
subset
B.
of B. Similarly, I am asking here, what is the range set of T? Is it RT? Okay, RT will be a subset of
W. Yes, sir.
okay. So RT is a subset of but how can you prove this? What steps you prove that RT is a subset of W?
If we take any element from RT,
Okay.
so there exists one element or vector which belongs to V vector space. X ले लो,
Yes, very
fine.
good.
So I equal to मतलब
Very
image.
good. Okay. And this Y belongs
So
to
by belongs to RT.
Y belongs to RT. This implies Y belongs to RT because it is the image of some vector X. Right?
Yes.
So no, we want to prove
So
Y belongs to W.
yes, sir. So now, sir, RT is a subset of W. So by
Want to prove that RT is a subset of W.
Shashi, we want to prove that कि RT is a subset of W. आप ठीक चल रहे हो. अब यहाँ से Y is equal to T of X. So what is the next step? X कहाँ belong
सर
कर रहा है?
TX W को है.
But TX belongs to W. Why? Why?
Sir, because it is image.
No, see here.
Sir, because जो
Defined from V to W, that means the image
T
of belong to vector
W.
space W. Right? Because
Yes, sir.
E is defined from V to
W.
W. And it is a linear transformation, right?
Yes, sir.
That TX will belong to
W.
W. That is Y
W.
belongs to W. Right?
Yes, sir.
That this implies
this RT is subset of W.
Right. So now we can call any other student for second question.
Yes, Shashi, very good. Aman, unmute your audio.
Aman, can
Yes,
we
sir.
prove that it is a non-empty set? How?
Yes, sir. Because it is a transformation. It is a map. RT is a map. There exists one element we will get from V to W. मतलब mapping we will get
So which element you think it is?
sir
Surely
identity element.
which identity?
W पे identity element मिलना चाहिए sir mapping.
Zero vector. You want to say
Yes.
zero vector of,
Yes, sir.
as we know, zero vector is always mapped to a zero vector
Yes,
of
sir.
W. V will always be mapped to zero vector of W. So zero vector is always there, right?
Yes,
So
sir.
therefore we can say RT is a non-empty set, because at least one vector, zero vector is there. Now if of W, it is a subspace of which vector space? W. So RT is a, how can we prove
Jashneet, Jashneet, unmute your audio.
what property we use? It is just revision of your previous lecture,
Jyoti,
nothing else.
Yes, sir.
Yes, Jyoti, how can we prove that it is a subspace of W?
Scalars alpha 1, alpha 2
Okay. And
belonging
next, Jyoti.
I think
Okay.
Khushbu, unmute your audio.
Yes, sir.
Yes, Jyoti.
Yes, sir. Given any two scalars alpha 1, alpha 2, take any two vectors v1, v2 in vector space V.
Okay. Now we are proving RT is a subspace of
Yes, sir.
W.
Then after that, we know that T of V1 belongs to R of T.
T of V1.
R of T and T of V2 also. And write T of V1, comma T of V2.
Okay.
Plus alpha 2 of V2 also belongs
How
to
can
R
we
of
prove
T.
that? What? We need to prove it.
Yes, sir.
Jyoti, how that RT is a subspace? How we can prove this? What is the condition?
To prove the subspace, we can to prove anything for a subspace, we have alpha x plus beta y
Alpha
belongs
x
to
plus
that
beta y.
subspace, means W.
You have
Yes, sir.
taken
But
T
for
x.
x will be R of T.
So first take T.
So we can take it as y1 and y2.
Yes, sir.
Or W1 W2, or you can take W1 W2.
Okay, also we can also take it as W1 or W2. Right.
We can prove.
So we want to prove alpha 1, it as alpha 1 TV1 plus alpha 2 TV2. Now what we will do next step?
ज्योति T क्या है? What is T?
It's a linear transformation.
So,
Yes, you will get an idea.
so automatically this will belongs to R of T.
No. Take one. You are
Think
missing
on
one
it.
step.
Alpha V1 plus
That's one, so we can write alpha of TV2 equals to T of alpha 1 V1 plus alpha 2 V1. Alpha 1 V1, can we say that this alpha 1 V1 and alpha 2 V2 belongs to V? Why?
because this is
Yes.
the linear combination.
And any linear combination of two vectors also belongs to that vector.
Yes.
Vector space. V therefore V2 belongs to R2. Because by definition of range space, for every V belongs to vector space, we have an image that belongs to RT. Now we can say that this belongs to RT. So we have taken two vectors W1 and W2, and alpha 1 W1 plus alpha to W2 belongs to RT. Therefore, range space is a subspace of V. Prove that RT is a subspace of
Rohit sir, Gaurav sir, give them.
So if you have understand this concept, then you can write yes. All the students, please reply. You have to reply either yes or no. Okay. So I think all the students are replying yes. Let us move to the next definition. Very important. Kernel of LT. LT. Now, what is kernel of LT? If V and W be two vector spaces and T be a linear transformation defined from is defined as NT equals to all X belongs to V such that the image of that X is zero vector in W. Means all those X whose images are zero vector in W. Now again my first question, set of NT. Yes.
Muhammad Umar Farooq. Yes, Muhammad.
Please observe this definition again and reply what will be the superset of NT.
Pallavi Saini.
now I will check how many of these vectors are linearly independent, and that will form set for taking P as a matrix. Now I check the linear independence of these vectors. How can I check? Okay,
Yes, sir.
linear independence in a matrix form.
Sir, if the determinant is non-zero, then it is linearly independent.
But determinant should be a square
Yes, sir.
matrix. It is not a square matrix. We cannot
Yes,
use
sir.
determinant to linear independence. What will we use?
Sir, echelon matrix.
Yes, row echelon form. We can reduce. Okay. So in order to reduce it row echelon form, what we use?
Sir, R1 minus R2 we can use.
Elementary operations, you can say.
Yes, sir.
Okay. So first operation we are using is making this element 0. Then we are using these elementary operations. R2 equals R2 पे operation लगाया R2 minus R1 applying and they're applying elementary operation on R4. So this is 0 minus 2 0. This is 0
0
0. This is 0 minus. This is 0 0, so this is minus 1, right? So again applying in order to make this element identical. We are applying operation on R2 as minus 1 by 2 times R2. So this is 1 1 1 0 1 0 and rest is same. Again we are applying R on R4. So when I was studying in, I hope you all have about elementary operations in +2 in the chapter of matrix. When I one question came to my mind that why these elementary operations are like this only. Ri alpha times Ri plus Rj. And the answer I get when only I studied about linear algebra. Can you tell why these are like this? Sorry, it is 0. So again, R3 minus R3 minus plus R3 plus R2. So here I get 1 1 1 0 1 0 0 0 0 0 0 as minus 1 into R3. Now, please, can anybody tell why the elementary operations are like this?
Yes, Arup Datta.
Yeah, if we do this type of operation, then it will not change the.
Which properties?
So whatever the properties, the
Yes, actually, that we already studied it in +2. So, and the matrix came after the idea of linear algebra only. So we just because of linear algebra, there is only these linearity property is a very important factor. So the linearity saved. Can you see now what type of property you are preserving? Now we want to preserve the linearity property. We are using alpha x plus beta y everywhere. Whether we are talking about subspace or we are talking about transformation, we are preserving two operations. So these are want to preserve the linearity. That is why we take elementary operation as the scalar multiplication and addition of two vectors. Can you understand?
So in third row, 0 1.
Yes, 0 and it becomes -1. Then I multiplied R3 by -1 and it becomes 1.
Okay, sir.
So that's okay. There are 3 non-zero rows only. So that means out of these 4 vectors, 3 are linearly independent. So therefore, in this row echelon form, we can conclude that the non-zero rows or number of non-zero rows are 3. That RT. That is, basis of RT is B equals to 1, 1, 1. What is the dimension of this RT?
So 3.
3. Okay. Dimension of RT is 3 means rank is 3. Right? I hope the idea is clear. If you are clear about range space, then you can write yes. If you have any doubt, then you can ask. Please write yes if range space is clear. The response of every student is so. Let us move to next. That is nullity. So about nullity. First of all, these are and V elements of V means elements of R4. Then it will be of the form X, Y, Z, and T. And which elements? All those elements whose image is what? 0, 0, 0. If you want to consider, we are considering all the X, Y, Z, T. 0. So then X, Y, Z, T belongs to W. Oh, sorry, NT. Formula of X plus Y plus Z plus T, X minus Y, X plus Y plus T. So from here I will get 3 equations: X plus Y plus Z plus T. Second is X minus. This equals to 0, 0, 0. So from here I will get three equations. First one, x plus y plus z plus t equals to 0, x minus y equals to 0, y plus t equals to 0. Yes. Now I want to I want to find these all these x, y, z, t. How can I find what I want to find from? Can anybody tell? Actually, I want to find independent solution set, right? So first of all, in the matrix form, then you have done in +2 that how can we write a equation ax equals to 0. So we write its coefficient matrix. So coefficient matrix is 1, 1, 1, 1, 1, minus 1, 0, 0, 1, 1, 0, 1. Coefficient. So I want to check how many these equations are linearly independent. ऐसा तो नहीं है कि ये तीन इक्वेशन जो है वो इसको सॉल्व करेंगे और वो दो इक्वेशन में independent equation. So I am writing this form. So in order to check whether these equations are independent or dependent, I will reduce it in an echelon form. I'm writing the coefficients and then I will reduce it in echelon. Surely these equations are independent, right? So let us apply again the elementary operations. So first one, R2 and R3. R3 will be R3 minus R1. 1, 1, 1, 1. 1 minus 1, 0. Minus 1, minus 1, minus 2. Minus 1, minus 1, 0, 0, minus 1, 0. Multiplying by minus 1, I'll get 1 1 1 1 this one and 1 0. So these are independent equations, right? Further, I cannot reduce it to any 0. So these are already in echelon form, right? So unknowns. Three equations and 4 unknowns. So that means from these three equations, let me write these equations: x plus y plus z plus t 0, 2y plus z plus t is z equals to 0. So here I am getting 3 independent equations and there are 4 unknowns. From these, find out the values of 3 variables in terms, right? Suppose z equals to 0. This implies z equals to 0. And y equals to some constant k, then I will get t equals to minus 2k. If I put z0 and y equals to k and t equals, get the value of x. So here the value of y is k, value of z is 0, value of t is minus 2k, equals to k. Therefore, the solution, if I take one variable independent, that variable, then I will get the value of x is k, value of y is again k, minus 2k. So I will get k times 1 0 minus 2. So this forms the basis set of this solution. Solution, there are infinitely many solutions and these solutions are just a scalar multiple of this vector. So therefore, the basis set of this solution space is 1 1 0 minus 2. So can you tell NT?
Sir, 1.
So 1.
1. So dimension is 1 because there is only one vector in. Try to find out the solutions dependent or not. So when we using row echelon equations and 4 unknowns. So from here we can conclude that there is only one independent variable. right? So suppose if we have two equations and one variable, two variables and one equation, then obviously we can write one in the scalar multiple of other. So there is only one independent variable. Similarly, if we have three equations and four unknowns, then obviously we have only one independent variable, right? So that we can take any one as any of x, y, z, t as fixed. So we fixed y. Let it be an independent variable, and we y, right? So we found that t equals to 2 minus 2 times x is equals to y, and z is independently 0. So here we write x, y, z, t in terms of k. Because we put y equals to k. So ultimately we get are just the the scalar multiplication of this vector. So this vector form the Bayesian space of this, right? So, and what is the solution? Solution means, what is the meaning of solution? Solution means all the x, y, z whose image is 0. So we were searching for these x, y, z, right? So finally we get the basis and dimension. Now if you want to ask anything, then please you can ask. Please unmute your mic and ask. Yes. If everything is clear, then you can write yes. Otherwise, you can ask. The rank D and which is the, so this is the important result. This is the very important result in which, so that is what we have. We have the vector spaces and any v is finite dimensional, then rank T plus nullity T. So I'm not going to in vector spaces and basis dimension, in which I have picked. That is why I have picked this. What is the meaning of rank nullity? Range space, dimensions of vector space V, right? Where T is a
Very important result in the
yes, very important.
And try to relate the proof with.
Yes, yes.
any relation between linear transformation and matrix? Gaurav sir, relate transformation, linear transformation and matrix.
Can we move forward, sir?
As you wish, sir. You have another 10
We
minutes.
discuss this matrix representation. So please take few minutes if you understand. So it is just using the basis vector B, images of that basis vector in W, and we are using again the basis vector of W to represent this as a linear combination of the elements of basis vector of W. So when we write combination, so particularly we are writing the images of bases in V. So that will give the coefficient matrix of that will be the matrix associated with transformation. So if you observe here again a matrix is associated with two sets, that is the basis set of V and W. Now if V is equal to W, in that case we have only one basis, B in terms of x1 only, x1, x2, xn, xn. So if V is here, the order is m cross n. If V is equal to W, then what will be the order of the matrix? Yes. Please write yes if you know the answer.
Please repeat the question.
So my question is, if V is equal to W, two vector spaces to different. So my question is, if I take V equals to W, same vector space, a transformation, then what will be the order of a matrix? Then what will be the order of the matrix associated with T?
Yes, Akanksha Thakur.
It will be M cross M.
M cross N or N cross N, yes. If or dimension of N, then order will be N. I think, sir, it's already 6:38. So if you have any doubt, then you can ask. If you have any query, then also you can ask. Otherwise, we will close the session. Yes, Sangeet sir, over to you.
Students, if you have any doubt, then please ask. Otherwise, we shall close this session. Or you can write in the chat box also. So I hope you all understand it. So thanks for your response. So students, we are closing. You can leave the meeting. Let us thank Gaurav sir for this session.